Welcome to section 7.5. We're going to be dealing with systems of inequalities, and we're looking at graphing these inequalities on a coordinate grid. So if you have multiple colors, please pause this and grab your multiple colors because we're going to be doing 3, 4, sometimes 5 inequalities at once on a graph. Okay. I'm going to start out pretty light, but let's start with the original. What makes an inequality different than an equation? Because in an inequality, there are a range of solutions rather than just one solution. Okay, so a range of solutions instead of one solution. And so here we go. X is greater than or equal to 2. Well, x equals 2 is a vertical line at 2. But because it's equal to, I'm going to make this a solid line. Everything greater than that is everything over here. Okay? My second equation, y is less than 3. So I go up to y equals 3, and because it's just less than, I'm going to dot my line because I don't want it to include it in this solution set, and everything less than is below it. The last one, we're going to solve for y, and I'm going to save us a little bit of time. You end up getting y is less than negative 1/2 x plus 5. And so if I go up to 5, negative 1/2 means I go down 1 and over 2 when we talk again about slope. And you end up getting what we would like is a dotted line because it's just less than. I'm going in both directions just to make sure I have as much of the line as possible. And I just tend to put a dot in between them. The last thing you want to ask yourself though is which way do I shade? And what we're going to do is pick the point 0, 0. So I'm going to test 0, 0. And I'm going to plug it in my equation. Is 0 less than, if I get a 0 in for x, it's just 0 plus 5, so 5. Because the answer is yes, then I'm going to shade towards 0, 0. If the answer were no, then I would shade, I would shade away from 0, 0. Now let me change my color so you can actually see what I'm writing. But when graphing inequalities, start by graphing the general equation. Okay. When the inequality has a less than or a greater than, then the line will be a dotted line. If it's less than or equal to or greater than or equal to, the graph would be a solid line. And then we're going to use a test point. And again, most of the time that test point will be 0, 0, unless our equation goes through 0, 0. And so this is kind of the first idea going through. And so what we give you is a general tip, and it says use different colored pencils, and that's what I would suggest to you. So for this quiz, 7.4 to 7.6, please make sure you have a couple of different colored pencils or crayons or whatever. I will have some in class, but even for your homework, you're going to want multiple colors. So let's slide down, and let's look at this second example. I'm actually going to start with this y is greater than 2, and then because it's just greater, I'm going to use a dotted line. Greater than 2 means everything above it. And you'll notice I'm not doing a whole lot of shading, just in the fact that we're going to put multiples of these on the graph, and it's going to get kind of messy. Okay, let me pick another color, and let's solve this first equation. Once you solve it, you end up getting that y is less than negative 1/2 x plus 8. So I'm going to graph that. Let me go up to 8. 1, 2, 3. And negative 1/2 means I go down 1 and over 2. And I'm going to go left 2 and up 1. And because it's just a less than, I'm just going to make this a dotted line. And again, we got to figure out which way to shade. So we're going to test a point. Because it does not go through 0, 0, I'm going to use the point 0, 0. Is 0 less than 8? The answer is yes. So we shade towards the origin. All right, last one. I'm going to make this third equation equal to y. You end up getting that y is less than or equal to x minus 2. So negative 2, x means there's just a slope of 1. I try to put in as many points. Because it's greater than, or less than or equal to, I can actually extend this line. And I'm going to test the point 0, 0. Is 0 less than or equal to negative 2? The answer is no. So this would be shading towards 0, 0. I'm going to shade away from it. And I'm going to find a color. Let's go this gray color where I can find the intersection. Okay, so I can see there's a little bit of overlap right here. Oh, it's a dotted line. Hold on a second. Let me move this out of the way here a minute. Dotted line 2, and I gotta keep going out to where the blue line hits, because it looks like this is a solid line and where they intersect, and then another dotted line here. Now, because 2 dotted line means we put an open circle, and because part of this is not included, we also put an open circle here. We put a closed circle only where 2 I'm sorry, none of them are, these are all open. I apologize because this is a dotted line, this is a dotted line, and this is a solid line. So we're going to put open circles here as we go through, and so we're looking at these. And we don't necessarily consider these vertices because they aren't actually included, because it's not included in this set. So all of this stuff, though, in the middle is our solution set. Okay, so that's the first example going through. Let's flip the page and let's figure out a couple more of these. Let me get to a better color. Let's go orange this time. My first equation, I want to solve this. It's y is greater than or equal to x squared minus 1. X squared is a parabola, and we've shifted it down 1. So let me plot some points. And we end up getting, because it's less than or equal to, we can have a solid parabola. Now, we want to check, basically, are we shading on the inside of the parabola or outside of the parabola? And so I'm still going to test 0, 0. If I put in a 0, is 0 greater than or equal to negative 1? And the answer is yes. So we're going to shade on the inside because the origin occurs on the inside of our parabola. So let's grab another color. And if I solve this one, I get y is less than or equal to x plus 1. So I'm going to graph this. And because it's less than or equal to, I can make this a solid line. And again, we want to know where to shade, so I'm going to do 0 again. Is 0 less than or equal to 1? The answer is yes, so we shade towards the origin, which is this way. Now let's pick another color. Where do they intersect? You can see they cross together here and they cross together here with this line and then this kind of curve. This portion here in the middle is our intersection. We call it a feasible region. It's the region that has the solution set. Because these are both solid lines, we have what we call a vertex at the point 2, 3. We also have another vertex at the point negative 1, 0. And so because they're both solid lines, we consider them vertices. So just kind of keep in mind, I would kind of label your vertices if you can. All right, let's go to the next one. I'm going to solve the first equation. You get y is greater than negative x plus 2. So I go up to 2. My slope is negative 1. I'm going to get the kind of general idea. Oh, it should be a dotted line. Let me see if I can dot it the rest of the way. If we try 0, is 0 greater than 2? The answer is no, so we shade away from the origin. Let's grab another color. I apologize. Y is less than or equal to negative x minus 3. So negative 3. And I hope this is a greater than or equal to, so this can be a solid line. I hope you start to see something. Is 0 less than or equal to negative 3? The answer is no, so we shade away. And so the question is, where do the two intersect? They don't, so our answer is no solution. You're seeing the two parallel lines. They don't have anything in common, so we just say no solution. Our last example is a story problem, and I'm going to slide down so that we can look at that. And then this will be it for section 7.5. Take a look. A store sells two models of computers, Dell's and Macs. Because of the demand, the store stocks at least twice as many Macs as Dell. The cost to the store for the Macs is $1,200 and the Dell's is $800. The management does not want more than $8,000 in computer inventory at one time, but it wants at least 4 Macs and at most 4 Dells. Okay, so we are going to have to create our own inequality. I'm going to start with at least 4 Macs and at most 4 Dells, because I think that's the easiest. If I want my Macs to be at least 4, that's got to be greater than or equal to 4. If I want my Dells to be at most 4, then I want my Dells to be less than or equal to 4. Okay? They want at least twice as many Macs as Dells. So the Macs are twice as many as the Dells, and I want at least, so greater than or equal to. The only thing we haven't included is the money. So let's talk about that. $1,200 for the Macs plus $800 for the Dells. They do not want more then. So at most $8,000 in computer inventory at one time. Okay, so our job is to basically put these on our graph and kind of figure out what happens. Now instead of X and Y's, I'm going to make this Macs and Dells, just so we're kind of looking at this. You know what, actually I'm going to switch that because I have an equation that has Macs and Dells here, and Macs are in terms of Dells. I'm going to make the Y Macs and the X Dells. It won't necessarily matter, but to me it makes a difference because I have one equation of one variable in terms of another. So, all right, here we go. Macs have to be greater than or equal to 4. So 1, 2, 3, 4. Max, Y, right? So Y has to be greater than or equal to 4. So 1, 2, 3, 4. It's a greater than or equal to. So because it's greater than, let's go this way. Let me change my color for the Dells. Dells has to be less than or equal to 4. So here's 4. Whoop, not quite a straight line. Less than or equal to. One thing we didn't really talk about, but the Macs have to be greater than or equal to 0, and so do the Dells. You can't really have negative values, so it probably should, we should discuss the fact that it should be stopped here and stopped here no matter what. So just kind of keep that in mind. Let me get another color to do this one. the max are greater than at least 2 times the del's. So if I start here and my slope is 2, I go up 2 over 1, and I have a solid line. Do I want to include 0? It goes through 0, 0, so let's pick another point. If I pick the point like 1, 2, and I plug it in knowing this is the del's and this is the mac, what I'm saying is 2 greater than or equal to, I don't want to pick the 1, 2, I'm sorry, how about 1, 3? Is 3 greater than or equal to 2? The reason I can't pick 1, 2 is it's this point right here. The answer is yes. So 1, 3 is here, so I want to actually shade it this way. And I hope that makes sense. This is kind of a messy graph, but I don't want to include an actual point on the line, so I picked this one. Let me get a different color. And I apologize up front, the bell will ring again, but I want to finish this before anything goes on. But last one, take a look. We want to solve this equation in terms of m. So m is less than or equal to negative 2/3 d plus 6 2/3. Okay, and I'm just going to kind of approximate this a little bit. But 1, 2, 3, 4, 5, 6 2/3. So we're like right here. And then it's saying go down 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. And it's greater than or equal to, so you get this line. And so as you look at this, now we want to check 0, 0 again. Is 0 less than or equal to 6 2/3? The answer is yes. So I get all of this shaded down here. And I'm going to change my color one last time. Let's go bright red or orange here as we go through, because I want to look at this intersection. And this is where I intersect. And so when it says describe possible inventory levels, what it's talking about is the fact that, let's look, I could have, as I look at this, 1 del and 3 max. Or I could have 2 dels and 1, 2, 3, 4, 5 max. And this is the kind of idea. I could pick points in here. I could have 1 del and 2, 3, 4, 4 max, or 5 max, or 6 max. I mean, it's kind of looking at this saying, okay, what are the possibilities for going through? Now, these vertices are also indicators, because if you look at this, this is a fraction, and you're never going to have a partial amount, but that would get me the $8,000. But we know that partial, you can't have a part of a computer. Same thing here, 6 2/3, you're not going to have 6 2/3 of an actual computer. So just keep in mind as you're going through, this is a story problem. You do need real, actual answers that work. These are a couple of possibilities. Okay, so that's the end of section 7.5. Again, make sure you have multiple colors for this homework, and we'll go from there.